acidity and pH. What we're going to do is we're going to calculate pH. Acids produce H plus or H3O plus ions, one or the other. It's the same thing. Hydronium is what we usually go with there. Hydronium ion is more correct. So when you talk about pH, the P in the pH means a negative logarithm. Logarithms are exponents, so it's all you gotta remember. Logs are exponents, exponents are logs, and you're okay. So what does that do? Is that means pH is the negative logarithm, or the exponent, on the hydrogen ion concentration, the molarity of the acid. So if you have a molarity of the acid, the hydrogen ion concentration, or hydronium ion concentration, same thing, is 1 times 10 to the negative fifth. The exponent is negative 5, but it's the negative exponent. So a negative logarithm of 1 times 10 to the negative fifth, you can use calculators if you want to, it's going to be 5. So the concentration is 1 times 10 to the negative 12, the pH is equal to 12. So whatever the exponent is, you change the sign, and that's what it is. You can go the other way around. You can start with the pH, say it's equal to 8. If the pH is equal to 8, then the hydrogen ion concentration is 10 to the negative pH. So that would be 10 to the negative 8, and in scientific notation that turns into 1 times 10 to the negative 8 molar solutions. These concentrations are molarity, or molar solutions from the last lesson. Okay? If it's not a whole number, if it's not a 1 times 10, or if it's not a whole number pH, you have to use a calculator, and that's extra credit work. So if it's 3.2 times 10 to the negative 2, you'd have to, on your calculator, the negative log of that, and then that would come out with your answer of pH. Or if you know the pH is not a whole number, say it's 11.3 is the pH, then what you do is you 10 raised to the negative 11.3, and you'll come out with the scientific notation number for that. Each change in pH is 10 times stronger. So if you're going from 3 to 4, from 4 to 3, opposite direction, so lower, stronger. So that means this is 10 times stronger than the 4. If you're going from 8 to 3, that's 5. That means it's 10 to the 5th power, or 10,000 times stronger. So every time you go up 1 pH, the strength is increased by 10. There is a, we'll do this, strength of acids and bases, electrolytes, how they are interrelated. Just real quickly here, strong acids makes lots of hydronium ions. we've covered that before. Weak acids make a few hydronium ions. So the stronger the acid or the base, the more ions are produced. If it's an acid, you're going to be making H3O plus. If it's a base, you're going to be making OH minus. So if it's weak, you'll have less ions. If it's stronger, you make more ions. You can have a pH change. A little bit of a strong acid will make the pH change as much as a lot of the weak acid. So the stronger the acid, the less quantity you need to change it. Again, that's not too difficult to know. Also, if it's a strong acid, it's a strong electrolyte. If it's a weak acid or base, there are weak electrolytes. The difference between electrolytes and acids, electrolytes produce any ion, sodium ions, chloride ions, whatever it is. An acid must produce a hydronium ion. A base must produce an OH minus ion. So these are subsets of electrolytes. So it's like some quadrilaterals are squares. It works like that. Water will ionize with itself, which means if you have two H2Os, one of the H's will join up with the other one, and you'll make H3O plus OH minus. So water is chock full of acids and bases. The thing is that you won't get hurt when you drink water is because you have equal numbers and they cancel out. So every one of these will make one of these and they cancel out. Water is neutral because of this, and a pH of 7. Where do you get that pH of 7? Well, it comes from the relationship between the hydronium ion and the hydroxide ion. If you multiply those together, if you have more on the hydronium ion, the hydroxide ion goes down. They're inversely proportional. So if you have less acid, you're going to have more stronger base part. The relationship there, if you multiply them together, is experimentally found to be 1 times 10 to the negative 14. So if you have the hydronium ion concentration is equal to 1 times 10 to the negative 5. If you plug that in there, you'll get 1 times 10 to the negative 5 times hydroxide ion concentration equals 1 times 10 to the negative 14. When you multiply powers, you add the exponents, so negative 5 plus 1 will give you negative 14. The answer is negative 9. So the hydroxide ion concentration is 1 times 10 to the negative 9 molar. These are molarities on the concentrations. If you're given the pH is equal to 3, and it's a two-step problem, you got to find out that the hydronium ion concentration is 1 times 10 to the negative 3 molar. So 1 times 10 to the negative 3 times the hydroxide equals 1 times 10 to the negative 14. Subtract those. Hydroxide ion concentration equals 1 times 10 to the negative 11. Now, if this is not a 1 times 10, you'd have to use your calculator and actually divide 1 times 10 to the negative 14 divided by whatever the concentration is. That ends this lesson on acidity